Okay, I'm just going to start by giving a short introduction. So I started my career in computer vision, and over the past few months, I've been working on a lot of LLM projects. I cannot talk about those projects due to confidentiality, but I thought I will give you a quick introduction to RAGs. And it's a very big topic. The ecosystem is big, but I did my best to cover as much as I could. And like Bijan said, if we get an opportunity, we will get into the implementation details in another session. So I'm just going to share my screen. Can you see my screen?
Yes.
Okay, good. Okay, so we know that we have been building systems with LLMs. We have ChatGPT and a lot of other tools. And the agenda, I thought I would first start by talking about the limitations of large language models and how it has led to retrieval augmented generation techniques. Then I go into a bit deeper into why we need RAGs, the architecture of building such systems, then some of the challenges I have personally encountered while building such systems. And I will briefly talk about some advanced techniques and evaluating such systems in the end. Of course, evaluating such systems is an open research topic, so I don't get into the depth of evaluation, but I think this should give you a very good understanding of building production grade RAG systems. So one of the limitations of large language models is, at least before GPT-4, that we had an issue with the context length that we could send to OpenAI. And there is, of course, the issue of data bias and fairness. And the information was limited up to a certain point of time. But more than I didn't cover on the slide, but most important is the data security and privacy issues. If you are working on an enterprise application, it's not possible always to train your model with OpenAI or some of these large public models. So that got us to retrieval augmented generation. So what it does is it enhances the performance of large language models by giving contextual information and getting the answers related to the enterprise data that you have. So just imagine you're working in a company, you're building a chatbot, and you have a lot of data collected over the years, or onboarding tool for your company, and this is very private and sensitive data, and you don't want to train your model on such a data. So what you could do, you could enhance the performance of LLMs by using this contextual information, sending it to the generator or the large language models and getting a response. You could, of course, there is this discussion between using open source models or a service like large language models, and that's up for discussion. But this is, in essence, what is retrieval augmented generation. So let's now dive a bit deeper into the key components of RAGs. At a very high level, RAGs consist of a retriever and a generator. So retriever is something like a vector database through which I can retrieve semantically relevant information. And generator will be an LLM like GPT-3 or an open source model on Hugging Face, etc. But there are, of course, other components as part of building such a system. We have the interaction between the retriever and the generator, and we need to constantly get feedback from both these systems. If you are working in a very narrow niche area, for example, legal or medical, you would want to train your own LLMs and then combine it with RAGs. Then you also have to convert your textual audio or any data that you have in whichever format you have to convert it into a latent space in an embedding space, and that embedding space is then used to retrieve the information. And we also need attention mechanisms that's going to be used by both the retriever and the generator. So why do we need RAGs? First and foremost, it improves the performance of large language models. It provides more accurate and precise answers. It reduces development effort. it's not possible always to train your own model. You can use different prompt engineering plus RAG techniques to build your application. It increases scalability, and it of course reduces hallucination. Think of that you always need you need to cite some information if you have an enterprise data set, and you can use RAGs to get the explainability of your of the answer that you for the query that you have asked. So how are we looking with the time, Vijan? Do you have any questions that I could already answer?
Yeah, sure. So we got a quick question on Swati, and then I think there are more questions. I'll kind of talk about those as well. But how do RAGs increase scalability? Maybe you can kind of go a little bit deeper on that. That'd be great.
Yeah, so think of imagine you have a lot of documents, and you just want to provide, you have a query, and you want to retrieve just the relevant information related to your query. And so instead of fine-tuning the model, you can just get the relevant information, a relevant chunk of data, and then send it to LLMs. That's what I meant by scalability, that it's not always possible to train your own model, especially in an enterprise setup or very regulated industry. So any further questions? You can always interrupt me because it's going to get...
No, that makes sense. Thank you.
Yeah.
Okay, perfect. So and then there's one more question. By the way, for those of you that are also interested in digging more, here's the link to the cohort program. I think a couple of people also asked me. Here's the link in case you're interested. But the next question that is asked is by Harsha. It says, when we say reduces hallucinations, how do we measure it and monitor, and if there are any benchmarks or test data sets that help you measure hallucinations?
Yeah, this is an active area of research. This is an open question. How do we benchmark our results? And it depends from, it's not possible to have a universal benchmark data set. It depends on the domain you are operating in. And it could be possible that you would have to create your own benchmark data set to evaluate the performance of the model. So back in the days when I was doing computer vision, we had open source benchmark data sets. It becomes a bit difficult with such systems, especially if it's in a very narrow niche.
Got it. Okay, so, and I think we have some talks on the topic of performance benchmarks, but I think there seems to be a lot of requests there. I've seen that before too. So note taken, we'll try to organize a session that kind of digs more into the basically evaluation metrics. I think that's really what it comes down to, right?
Right.
Okay, so I can see there's a couple more questions popping in. It says, can you give an example of like how RAG improves performance? I think you talked about it with the chatbot example. But maybe you want to kind of go a little bit deeper.
So let's look at a system. When you ask a query from OpenAI, especially if you're working in an enterprise application, you're trying to build an onboarding tool for new employees, and you have a lot of private data. Of course, LLMs would not know about this data. So you need to provide some kind of context to the query. So the prompt plus query becomes the new information, and then the LLM is used to generate a response based on the context. And that kind of improves the performance. So instead of just relying on LLMs, because it's trained on general data, it's not trained on any narrow data or a niche data set. And combining both will improve the performance of the response.
Got it. Thanks so much for that. I thought it might be helpful if I also quickly show one quick screenshot that represents how it's done. I just like searched online. I thought maybe that's helpful. Would it be okay if I quickly like share my screen?
Oh, sure. Yeah.
Is that okay? So let me quickly do that. Give me 1 second. I think maybe you can kind of talk through this.
Should I stop sharing? Or?
No, I think yeah, you could, and I think it automatically basically there you go. So maybe you can kind of talk about this one right here. Can you see the screen?
Yes.
Like I feel like kind of this is like a good summary of like what happens. And you send a request, it goes to the specific knowledge base, comes back, goes to the LLM and continues. Curious to know if there's anything you can kind of share by looking at this.
I have the architecture in my next slides. So I
Oh, do
think,
you? Oh, okay,
yeah,
got it.
it
All
would,
right, then I'm gonna stop sharing that. Perfect.
okay. It's going to become, this topic is a bit technical. So let's see. So before we understand about the individual components, that is the retriever and the generator, we should understand what are vector databases. So back in the days, we had keyword-based search algorithms. And now what we are trying to do is we are trying to find semantically relevant information. So when I write something, when I have a query, it's in a natural English sentence, and I have a database with all the documents, all the chunks that I've stored, and I want to find the relevant document based on the query that could answer my question. And for this, we are using vector databases. Why is it relevant to RAGs? Because RAGs, sorry. Okay, so why is it relevant to RAGs? It's relevant because we want to find precise information, and we want to find semantically relevant information. So it's not just a keyword-based search algorithm, it's something more complex. And vector databases provide us certain advantages. It's scalable, it can handle massive data sets. The retrieval time is fast, and it provides, of course, different similarity measures like cosine similarity, Euclidean. You could also customize it according to your own use case. But there are also challenges with choosing a vector databases or designing a vector databases that you have to ensure that indexes in your databases updated. So when you get new information or when the information has changed, you have to ensure that it is updated in the DB. And there is this entire space of vector database vendors in the market, and choosing which database choosing is a more strategic decision. But today I wanted to just cover the technicalities and not a question whether you should build your own one or you should buy one. That's a more strategic question for product managers. I think it's also covered in the course. So how do we enhance the retrieval with vector databases? We use nearest neighbor algorithms, and usually if you choose a vendor, it comes inbuilt with that database. If you have a growing document corpora, you want to maintaining consistent retrieval performance regardless of data set size is important. And it should support different similarity metrics, for example, cosine, Jaccard, etc. Of course, as product managers, you don't need to know so much the technicalities of these algorithms, but having a big picture view is important, I think. And so like I said, there is the retriever part and the generator part, and the retriever has a different algorithm, and a generator has a different algorithm, and we have to ensure that both can be integrated together. Any questions, Bijan, I could answer so far?
Yeah, so there's a few questions. So Harsha is asking what kind of vector database platforms are typically recommended? Like if you can kind of share, like I guess, what's the criteria of a good vector database that would be qualified here? Anything you can share there?
That's a very big discussion. So there are popular tools like Quadrant, Pinecone. Depends on a lot of factors: the cost, the data set that you have, the scale that you want to use it for. difficult for me to answer right now which one to choose. It's a more strategic decision that you have to sit down with the team and take.
Got it. I can see there's one more question. Maybe I'll go to the person that has raised their hand, Vino, and then I'll continue reading Harsha and Swati's questions. Go ahead, Vino.
Yeah, hi. This might be a novice question. The difficulty I'm having in my head is I understand the concepts as you're going through it, but I'm trying to sort of map how a solution would work when you're using RAGs, right? So I understand it secures your enterprise data and provides a means to query them and retrieve answers that are specific to your business. But what is the relationship between your vector database that has your proprietary information and an LLM? So I'm asking a question. The vector database most probably figures out the answer. What's the role played by the LLM after that? I guess
the vector database does not figure out the answer. It just gives you the most relevant information that would help to answer the question.
So it reduces the
it gives you the top 10 or top K relevant chunks that would be used in the prompt as a context, and then the LLMs will answer that question. So it is just for search and information retrieval and not for answering the question.
So I could be using my proprietary vector database with like an OpenAI or LLM.
Yes, exactly. Yes.
Thank you.
Is it kind of like taking a shot, like, you used to write k-nearest algorithms or whatever, you'd need to write code or you'd use graph databases and then write that to retrieve it. So vector database is kind of solving for that, simplifying that, right?
Yes, but it's not just keyword-based search. It's more based on the semantics.
Okay. Yeah.
All right.
That's
all right. So
got it. That was key. Okay, got it. Thanks.
Can I ask you a question? Can I ask a question? One last
sorry,
question.
Sorry, guys. One thing. Please raise your hand. Just so that we can control the flow of the session, because a lot of people attending, or type them here, and then we'll go one by one. And I apologize for kind of asking to insist on this rule, just because I want to make sure that we can make the best use of the time. So go ahead, Vijay, and then was it Vijay? Was it you? And then after you, or whoever was speaking, and then after you, we're going to answer 2 questions from the chat, and then we'll continue.
So does RAG use something called data loss prevention or something to avoid data being fed to LLM? So is that why RAGs, this contest is used to kind of as a security mechanism? I'm still trying to figure out what's the role of a RAG with respect to context, reducing the context sample space.
So when GPT-3 was released, there was a limit on the prompt that you could send to LLMs. So it doesn't reduce data loss. That is the job of the vector database. It will replicate your database if there is a server, if the server goes down, for example. What RAGs does is it will give you the relevant information to answer the question, to reduce the context length, and then you could send this reduced context length and the relevant one to the LLM to generate a response. So that is the primary advantage of using this system. Okay. Otherwise, let's say you had 100 documents and the context length would be too much. It would also incur you a lot of cost because for every API call, you would have to pay money, and you want to just send the relevant one that will help in answering the question.
Okay. So reduces the context size.
Yes.
Okay.
There are a couple other good questions that I think is worth maybe talking about quickly from Chaitali. She says, are you using vector databases only with LLMs or also for knowledge graphs?
Vector databases has many applications. It became popular because of LLMs, but you could, if your use case is just simple search, semantic search, without generating a response, you could just simply use a vector database. You wouldn't want to use it with the LLM. Depending
Okay.
on the use case, if it's a search or a question answer system that you are trying to build.
Okay. And then there's one more question. So I think Swati's question, maybe two more. Okay. One is from Swati. Can you share why generator and retriever might use different algorithms?
I didn't get the question.
Swati, do you want to explain it?
Maybe I misheard something, Bijan, because I think at the beginning somewhere, you're talking about retriever and I think it was generator you said might use different algorithms. So I was curious as to what is the intuition behind that?
Yeah, so there are different embedding algorithms. So how you convert your text into how do you convert it into an embedding layer, and how the LLM was trained, it could be different. And we wanted to, so let's say you created some embeddings in your vector database, and now you are using a different embedding for your query. And they both have to integrate with each other. That's what I meant, that if you used ABC embedding and for the prompt and another embedding for that's stored in the database, there could be some mismatch, and we want to avoid that.
Okay. Thank you. Still not
Okay,
100%, but I think that's enough for now. Thank you.
Okay, thank you. I'm going to ask one last question, and then we can continue, right? So the last question is from Harsha, asking, what is the architectural decision point where one decides that we've reached the limits of prompt engineering, so we need to kind of look into RAGs as a value addition, like, or how easy is it? Like, basically, I think at a very high level, what Harsha is asking is like, how do you decide, like, what are the criteria for deciding, okay, now I need to use RAGs versus not using RAGs, and just like kind of including it in the prompt? Yeah, that's the high level question. Curious to know if you have any frameworks in mind on like, how do you decide, okay, now we need to actually use RAGs versus we don't need it now?
So one is, of course, the response quality of LLMs is not good enough. And you want to provide some context to get that response. And that context could be to increase the relevancy of the information that you are extracting. That's when you would, so instead of sending all the 100, let's say you have 100 documents, instead of sending the entire corpus to LLMs, you would want to just choose the top 10 results that would help answering the question. That would be one use case. The other one would be privacy and security, and you might not want to use OpenAI. You might want to use your own private model, and that's when you would use it with RAGs to provide the more to increase the recall of your system. So I'm sure in the course you have learned about recall and precision, and increasing the recall out here would be important. In that case, you would want to use RAGs.
Yeah, that's coming up actually in this current week. So it's going to be on week one. I think people haven't.
So I think some of these concepts would be a bit difficult to grasp, but I just wanted to give a short introduction. And if there is an opportunity next time, I could dive a bit more deeper, because I'm trying to cover as much as I could to help you understand the ecosystem.
All right, so let's continue. I think given we'd love to answer all the questions. There are a lot of questions coming in, and RAGs are very important topics. We're going to have more sessions on this, but for now, let's continue.
Yeah, so this is a simple architecture. So in this architecture, I'm not covering topics like LLM ops and experiment tracking, etc. So you look at the architecture, you have your textual data, audio data, images, multimodal data, and then there would be a embedding layer that's going to convert all this in a vector representation, store it in a vector database. And now you are the person sitting in this blue box. You have a query. Your query goes to the embedding layer, gets the relevant information or chunks out of this embedding layer. And then the prompt plus the context is sent to the LLM. and then you get the response back. At a high level, this is how a RAG system would look like. But there are many other moving parts, like how do you monitor the RAG systems? How do you evaluate the RAG systems, etc., which is not part of this diagram, but it's an important role as a product manager that you have to keep into account. So the first step, of course, once you start building such a system is it would be for this presentation, I'm just talking about textual data, but it would be something similar for audio or for video or for images. So the first step would be processing the PDF documents. You have PDF, you want to convert these documents into text, and you have different tools in Python to do this. Second would be you want to handle multiple pages. It's not just a single page. You would have a corpus of documents split into different pages, and you want to extract the different sections and paragraphs. You want to extract the metadata, which will help in answering your query or filtering the results out. And the third point, garbage in is garbage out. You want to clean the data. You want to remove it. I've not mentioned here, but you also want to remove any bias in your data, because that would impact the final result if there is bias in your PDF files. And especially in regulated industries, that's important. And you also want to detect the language of the documents. So I'm based in Europe, and I work with a lot of multilingual documents. So this also becomes important. It's not just a monolingual document. You have to tag your results with the language. Tag the documents with the language. The next step is, of course, ingesting this data in your pipeline. So this is like any other data engineering pipeline. If you have worked on data engineering applications, I think it's something similar. It's along those lines. So first step is splitting your text into smaller chunks. And there are different types of splitters. There is a character splitter and a token splitter. So the issue with character splitter is that it could increase the token length, but it gives you very granular results. And if you use a token splitter, you already know the maximum length of tokens that you would send to LLMs, and you could just split it based on the tokens. But the disadvantage with token splitter is you would miss out on some information. And so you have to take into consideration both of these topics. Should I split it based on the characters, or should I split it based on tokens? So if it's something very easy, not so complex, you could use a character, but it's something more complex, you use a token splitter. So the factors to consider is the cost, the latency and speed, and the computational resources. Now the next part is the generator. So once you have the retrieved documents, you're going to send the prompt plus the context to the generator or to the LLM. So you embed the user's query. You convert the query into an embedding, and that embedding plus the context that's retrieved from the vector database will be part of the prompt. You pass the query embeddings to the vector database to find and retrieve documents that best match the query context. You create the prompt based on your use case. You call the LLM function, and then you get the response and you show it to the user. Now, as product managers, I think what would be most important for you guys would be how do I decide which retrieval models should I choose? Because there are several retrieval models in the industry. Some are classical machine learning models, and some are new deep learning models or transformer-based models. So Bijan, I'm not sure, have they covered the transformers so far? Or...
They're just getting into it.
Okay.
I think that's part of the week one. So some people have started, some people haven't.
Right.
But I think, yeah, you can just like kind of mention that it's one part. Yes, technology enables things like GPT for now, and then they can dig into it more later.
So there are algorithms like DF-IDF, which gives you the importance of a term in a document, and you can use that if it's something simple. But if you have very complicated documents, especially legal documents, you would use a or a medical document with hundreds of pages, you would use a BERT-like model to convert text into an embedding layer. And key considerations would be the domain. I think this is very important because different domains would require different types of retrieval models. You wouldn't want to choose a general model for, let's say, a legal use case or for a healthcare use case. You would want to have a healthcare model that's available, or you would have to build your own one. And you want to choose a model that can grow with your the app's volume and user base. So any questions I could answer? So.
All right. So there's one question that I thought was interesting, maybe worth kind of quickly talking about, and a lot of questions are coming in, was does OpenAI APIs let us implement RAG implementations through Assistance API? Or yeah, I think maybe you can kind of talk about what's available in the OpenAI context with regards to RAGs, and if these two are dependent, not dependent.
OpenAI has released its own vector database system, so you could use it. But I think the thing you have to consider is the cost. The cost of using the OpenAI system and the scalability of OpenAI system. I think it would be very expensive if the number of document or if the volume increases to a substantial level, it would become very expensive to use that. So that would be a key consideration.
Got it. Okay, let's continue, and then towards the end, I'll cover more questions. Actually, one more question from Chaitali that's interesting. She says, do you use open source German LLMs, or are you creating custom LLMs for your German customers?
I'm sorry, I can't talk about that.
Okay, perfect. That's fine. That makes sense. All right, let's continue.
Okay, so the next, so I already mentioned about splitting your text into chunks, and the two methods are character level splitting and token level splitting. The advantages of character is it maintains highest level of detail, capturing the small nuances. Challenges, it could lead to long sequence lengths and exceed the token limits. The advantage of token level is it stays within the limits of the token limit provided by OpenAI, but it might miss out on some information. And there is, of course, hybrid approaches. You could, for some use cases, you could use both character and token level splitting. And this is, of course, a strategic decision. You have to do a lot of experiments, figure out when should I use what. Now, once you have cleaned your data set, you have converted your PDF files to text, and you removed all the noise from the data set. You have to split this document into smaller chunks, and then these chunks are going to be converted into an embedding layer, and that's going to be stored in the vector database. So the important question is, how do you choose the chunk size? And there is no right answer for this. There is no one answer for this. It depends it depends on your domain. For some, it also depends on the use case. If you're just processing emails, it wouldn't matter what is your chunk size. But if it's something more complex, you want to provide granular information in your context, and then it becomes very important. So large chunks reduce the number of items to process, improving efficiency, but possibly diminishing the relevance. So it depends. The optimal chunk size depends on the source text characteristics, desired retrieval performance, and system resources. And in my experience, you have to experiment a couple of times to figure out the optimal chunk size. So this is I have struggled a lot on my use cases, but the only answer I would say is set up a experimentation phase where you experiment and figure out what would be the ideal. It's like hyperparameter tuning in the context of machine learning. So are we good on time? I have a lot more to cover. I'm not sure if I can finish
Oh, that's
everything.
okay. I mean, if we run out of time, then we could cover it in another session if needed. So I
Okay.
think
I
it's okay to
think,
go kind of deep on what you're going over and
yeah.
cover
Yeah.
anything
So
additional.
I wanted to cover the challenges, and I think I will skip a few slides. So initially, I spoke about getting you're converting the text to chunks, but one more way to improve the performance of RAGs is using metadata. So metadata could be title, author, keywords, language, date, etc. So when you get a query, you might want to filter out the results and then trigger the retriever. And usually most vector databases have support for storing the metadata, and then you use this metadata to reduce the information that you want to look for, and then run the retriever to get even fine-tuned results. And then the same process follows, that you get the information, you convert it into, you send the relevant information to LLMs and get the response. Now let's talk about the challenges of RAGs. First is, like I mentioned, if you have noisy data, it's going to affect the performance of your system. And you have to spend some time cleaning the data set, figure out, depending on your domain, you want to set up a process where you say, okay, what are the rules according to which the data set would not be considered valid? Is there a bias in the data? Are there any misalignment, or are there some cultural issues that you want to avoid, etc.? I think we covered the model compatibility. The next one is scalability. You want to keep your index updated all the time. You want to manage computational resources for large-scale model deployment. Then I spoke about evaluation. It's difficult to evaluate RAG systems because there is no universal benchmarking data set. It depends on the use case and the domain. You want to integrate industry-specific terminology in the systems, and you want to secure your data for effective fine-tuning. Now I want to talk about one of the challenges I have faced building system, and it's a very, there's also a research paper on this topic. It's called lost in the middle problem. So let's say you retrieve a big text, and now the system usually suffers is that it has been found through experimentation that the most relevant information is usually at the top of the text or at the bottom of the text, and not in the middle. So anything that's in the middle gets lost. So one of the solutions is to reorder the document, that you place the least similar one in the middle. That's not going to help you answer the question, and the most relevant and the least relevant would be at the top and the bottom. I'm not sure if I'm going too fast or no, or the concepts are a bit too advanced. So you could let me know.
What do people think? Let us know. What do you guys think? I think one thing that people are asking is if we can share the slides with them afterwards, so I can coordinate all that stuff with you all. Yeah.
Sure.
Go ahead, Kristen. I can see Kristen's hand is up. Maybe we can let one or two questions.
Hi, thanks for doing this. There's a lot of valuable information here. I do feel a bit lost with all of the content, and I wish we could have a couple more hours to go over all this. But one idea, Bijan, is I know you have a lot of these community sessions. Maybe you could think about, for every week that we go through the content, which sessions that have already occurred that we maybe should watch once we have that more of a baseline
I see
understanding.
Which ones are more relevant to the content?
Yeah.
Okay, that's a great idea. If we
just had this session next weekend after we review everything for week one, it would have more impact.
Got it. Thanks so much for that feedback. That's very helpful. Okay, yeah, we can do that. So what I can do from my side is those of you in the cohort, you guys have like a Notion page that includes all the previous community sessions. What we can do is kind of break them down into community sessions that are relevant to the particular week. But to be honest, the community sessions are ongoing, will always happen. So there will be, every time we have like new cohort members joining in,
Yeah,
the
I
first 2
get
weeks,
that.
it feels just a little bit uncomfortable for them because they're kind of like jumping into the lake and learning how to swim. But point taken, I'm going to try to address it as much as I can using the existing content that we got. Sorry to interrupt. Go ahead.
I see Chaitali has a question here.
Yeah, I think one question what I wanted to ask you is regarding the RHLF, right? Where you are employing human in the loop and also the reinforcement learning algorithms, the policy kind of algorithms across.
I have not personally used RLHF. Not be easy for me to answer that question.
Okay. And also regarding the pricing of this vector databases.
Yes. I could send some links on that. How to choose the right vendor and the price of different vendors. There is a nice website, but I don't have it with me right now, so I could send it to Bijan later on.
Sure, thank you.
So I spoke about lost in the middle problem and how do we improve this? There is one technique is to reorder the text, that you put the most relevant information at the top and the bottom and the least relevant one at the middle. And that could already help the LLM answer your query in a better way. And if you know of LangChain, it's a popular library for LLM use cases. They have an inbuilt long context reorder function that you can use so you don't have to build things from scratch. There are a lot of libraries providing functions out of the box. There is another library called Haystack, and it provides two popular functions that I have personally used: diversity ranker and lost in the middle ranker. So what it does, it ranks your document based on the relevancy of the information that will help in answering the question. And now this is going to be, actually, I just want to tell you that I am just covering 1% of the entire ecosystem. So whatever you have seen so far, it's just a tiny introduction to this topic, but I tried to cover as much as I could. And I hope I have not confused you all. But in the last section, I want to just cover some advanced RAG techniques that I have been using. And like we said, we could again revisit these topics once you get a high-level picture of this. So there are, like I told you, there are two ways to retrieve information. There is a semantic retrieval information, and the previous one was keyword-based. So now the question is it possible to use both of them, or should we only rely on semantic relevant retrievers? And the answer is depends on the use case. So I have used both. In some use cases, I had to use keyword-based searches when the application is a bit simple, or it's a very domain-specific knowledge base where you have certain key terms, and it would make sense to use those specific key terms to search for information. And if it's something very, very complex, you have hundreds of pages, then it wouldn't make sense to use keyword-based. And in some use cases, you might want to use both. You might want to combine keyword-based search algorithms plus semantic-based search algorithms. And there are different techniques to do this. I am just covering 4 popular techniques. The first one is concatenation of the results from the keyword-based retriever and the semantic search retriever that's popularly found in vector databases. Then there is the rank fusion algorithm, and there is a popular paper on this topic. So you re-rank, so you get the results from both, and then you re-rank to prioritize which one you should use. Then the third one is merging by scoring. So you get the relevant information from both, and then you rank and you give a score that will help in answering the question. And based on the score, you can choose the one that's giving the highest score. So what are some advantages of hybrid retrieval? It enhances relevance. It provides more coverage, so you get more relevant. You get a diversity of a diverse set of information. It's more resource efficient. So keyword based would of course be less expensive. You wouldn't have to use any neural network models to implement a keyword based filtering approach. And depending on use cases, it's adaptable. So combining both in some scenarios gives better results than just relying on one. Yeah, this is another topic, so I could take some questions if there are.
All right, are there any questions? So there's one question that is being asked is, are there, and maybe you can kind of provide this after the session, they're asking if there are any additional reading material or links that you would highly recommend everybody to take a look? Like, is there any sort of white paper, for example, that you think is great? By the way, a lot of people are also messaging me saying that the session was great. So looks like what you're sharing is resonating with the audience.
So I could write a book. I have plans to write a book on these topics, but I have just been experimenting and learning. So I have not referred to a book, but I could find something. Yeah. It's all my experience in the slides.
Okay,
You should write a
sounds
book,
good.
Neeraj.
Sorry.
Write a book.
Yeah.
We'll offer it for free to the cohort community members, and Felix says we'll cover for it. Please do it, Neeraj. We would love to have you publish the book. I think there are a couple questions that are coming in. This is an interesting one, and maybe you talked briefly about this. What are there any unique success metrics that you have to pay attention to when it comes to RAGs, or is it fair to say the success metrics are more or less the same as your model if you're not using RAGs? I'm trying to make Mahesh's question a little bit more generic.
It's mostly recall and precision. So you would, if you have the capability to create the labels of factual information, and then comparing the response of LLMs with the factual information, then you can calculate the accuracy of the system. But this is just one metric. There are some more advanced metrics, and I'm also researching on this topic. So I'm not an expert. I'm just a curious learner. Yeah.
Awesome, that's great. Thank you. Let me go to the LinkedIn page real quick because I think there are a couple questions that are also posted there. Maybe I can answer them. So, to be honest, this part, Navneet, feel free to add more clarity. I'm not super clear what you mean. You're asking, the vector database and embeddings are language agnostic, and so is OpenAI and LLMs in general. Then why does the language detection needed and at what stage? Didn't quite follow the question, but in case you did, Neeraj, go ahead and answer it. Otherwise, we can move on.
So like I spoke about the metadata, and you have a query, and let's say, and your corpus is made of both German and English documents. So if you have the language, you can filter out the results to look for information only on those German documents, because that's stored in the metadata. And then you find the relevant information in set of German documents. That's why we need the language identification. But if it's just English documents, you wouldn't need it. That's right.
Okay, perfect. Chitali, I think your question is more generic outside RAG, so if that's okay, I'm going to kind of hold off on it. Okay, Faiz, I'm going to answer your question offline. Trying to scroll up a little bit quickly, see if there's anything else that we need to cover. Is there a ranking problem? So, okay, Harsha says, so there is a ranking problem in the RAG architecture too. Okay, it looks like we've covered most of the key questions that are posted. Please let me know if anybody thinks that we haven't covered any particular questions, but we'll probably have another session. At some point, we're going to do a lab on RAGs. We just have to kind of make sure that it's simple enough for everybody to be able to go through it. Yeah, so we'll take care of that offline, and I'll keep you guys in the loop. Other than that, is there anything else that we need to cover, Neeraj, or I can have like a couple quick announcements on our side?
Yeah, I wanted to cover some advanced techniques, but I think it's going to be too complicated for now. Yeah. So we can stop out here, I think.
Okay, perfect. So what we could do is we could share the slides afterwards. Quick update. First of all, thank you so much, Neeraj, for coming in. This was really amazing. This was very productive, and really speaks to how fortunate we are to have you at our community for everything that you've done. We really appreciate it. For those of you who are interested, next Saturday, we're going to have one of the ex-AI product managers at Google, who's now working at SourceGraph, coming in and talking about what they're doing with regards to coding assistants, coding copilots with their company. I think the platform, the tool that they have, the AI assistant, is called Cody, and that's pretty popular. They've raised a lot of money. They have a pretty strong user base. So that's going to be a very interesting session. One more kind of quick shout out, if anybody is thinking about signing up to the next cohort, we've already started accepting applications. We're not replying yet. We're just currently very focused on the current cohort. If you're interested, just use the link that we submitted in the comment section. You can use it to apply for the next cohort, and we'll get back to you shortly. Other than that, for those of you that are going through the Saturday session of the cohort, we'll see you guys in a few minutes. We'll wrap it up pretty quickly. Thank you so much. Really appreciate you coming in, Neeraj. This was very productive, very helpful. Have a great day, everybody.